This is Kenneth Wong, Senior Editor for DE247. I came across Luminary Cloud, a startup in the San Francisco Bay Area, during the NVIDIA GTC news coverage because they were one of the early adopters of NVIDIA Omniverse Blueprint for real-time digital twin visualization. This month, the company is releasing an open-source SUV simulation model. You can think of it as a template for simulating the aerodynamics of standard SUVs, which you can take and then customize for further use. This is just the first in a series of models the company plans to release. Here's more on the company, its vision, and the product from Juan Alonso, CTO and founder of Luminary Cloud.
Yeah, so we're extremely excited about this because on Tuesday we're going to announce the first of a number of what we're going to call shift foundational models, which are large data sets of very high fidelity simulations and a physics-based AI ML model that's trained based on that simulation to be able to do inference about new shapes of SUV vehicles faster and more accurately than ever before. So Luminary Cloud was founded about 5 years ago, but for the first 4 years of the company we were in stealth mode, developing capabilities to change the way we do computer-aided engineering and analysis. So Luminary Cloud has developed a fluid thermal solution that includes CFD, heat transfer, and the combinations of those two in order to do analysis of external, internal aerodynamics, heat transfer problems in a cloud-native and GPU-native way that enables us to do simulations about 100 times faster than equivalent CPU-based solver technology. And it allows us to do it in a manner that is much more automated end-to-end. So because of our capabilities in GPU solvers and because of our cloud-native footprint, we are also able to marshal amazing amounts of resources in order to not just run one calculation quickly, but hundreds of simulations simultaneously, and therefore be able to create massively scalable simulation databases that can be fed as the input data to train models that then can be embedded into any engineering workflow. Yeah. So the physical solutions that we have right now compete directly with many of these CFD vendors, and our plan over time is to continue to increase our physics capabilities and the combinations between the physics in order to have multi-physics simulations. We're not there yet, but for the physics, the fluid thermal physics that we have, we think that we can do what some of these larger companies that have been around for very long, much better, much faster, more accurately, and without having engineers deal with all kinds of IT format conversions, etc. So in a truly end-to-end integrated fashion. So we have in the product today an AI assistant that effectively any user can type in a chat GPT type or LLM type of environment, anything regarding what we want to do as a user in the product. So set up a simulation with a far field at this distance, set the far field boundary conditions at this sort of values, speed, temperature, so on and so forth, and perhaps even sort of say something about the level of resolution or the level of accuracy that you want. The LLM in the product today can take all of that and actually, through calling all our internal APIs, set up the simulation automatically for the user. That's one example of what we can do. Of course, a natural language processing extension, so you can speak to the product rather than type, is a very logical extension that a customer that I visited yesterday was actually asking us about. So we are not pursuing AI for the sake of pursuing AI and just putting a little AI stamp on the Luminary product. We're pursuing AI to make a difference in the engineering workflows for analysis and for design optimization that most engineers want to pursue. So AI is an assistant, and we actually call it the AI assistant. It's making your job as an engineer simpler, faster, more repeatable, right? More reliable, etc., but it's not really replacing you. Eventually, when we combine this AI assistant with the shift models that we were talking about, and we have very quick inference, so sub-second inference for any new design, what you'll be seeing is that the AI assistant will also be providing recommendations as to how you might change a design to make it better. But again, every pursuit of AI within Luminary and as CTO, I'm in charge of this, is to make sure that we improve the ability to do engineering analysis and design optimization. It is exciting to see how quickly the world of physics-based AI and ML is progressing, which is different from the mainstream AI sort of applications. Write a paper for me, create an image for me, doctor this video to do something else, but rather that is trying to simulate the physical world in a much quicker and accurate way than we could ever do before. It's incredibly exciting to see how quickly this is evolving. The bottleneck is data and data availability. There's not enough data to train these models unless you can produce the data very quickly. So Luminary is building the platform not only to train the models, but also to be able to produce, curate, store, and use the data that's necessary to feed these types of models. So I think the sky is the limit. Things are changing very, very rapidly. Over the course of the next, I would say, 3 to 5 years, engineering design is going to be fundamentally altered from what we have been thinking about is engineering design for the past 30, 40 years.
For more on design and engineering related news, go to DE247. That's digitalengineering247.com. Until next time, I'm Kenneth Wong for DE.